Okay, welcome back everybody. So this week is a little bit of a light week in the C# class, and the reason is because it's really supposed to serve as a sort of breaking point. So everything that we did in the first part of the class is really about C# itself. Everything that we do starting now to the end of the semester is about full stack development and how you can use C# to achieve full stack development. So there are 3 videos in this module. This is the first one, and what we're going to do is we're going to talk about what is called multi-tier application design, and we're going to, over the course of the next 3 or maybe 4 weeks, build a multi-tiered application to deal with ABET certification requirements. That should be kind of an interesting thing to do via code logs. So just to kind of contextualize all of this in sort of where we've been, where we are now, and where we're going. Where we've been is we covered the absolute rudimentary basics of .NET and the fact that it runs inside of the CLR and the fact that it kind of compiles the same intermediate language as VB.NET or F# or all of the other CLI languages. And we also covered all of the sort of rudimentary C# syntax. And so over the span of the next couple of weeks, there are going to be some kind of recitation style videos that cover a little bit more of that syntax. But at this point, you should be able to do essentially anything that you could imagine with Java or something like that in C#. The additional language features we're going to cover are things like generics and things like dynamics. So those are not necessarily required to do C# development. They just make things a little bit easier sometimes. We've also looked specifically at WPF applications, and so we've built a couple of thick client applications. And what we're going to talk about today is kind of moving from thick client application development to kind of full tiered sort of web development, and all of the kind of philosophical changes that you have to make in order to make that shift in your head. So in this video, what we're going to start talking about for the first time is web service development, which in my opinion is the thing that is really C#'s quintessential strong suit, and that's because of a library called C# Web API, which we're going to make heavy use of in the server-side coding module. It's in 2 weeks. And what I want to do today is really talk about what web services are and how you can use them to kind of build a tiered application that looks closer to a sort of enterprise application than programming assignments that we've done in this class, and a lot of programming assignments you may have done in other classes as well. So if you think about our level of application development in C# right now, it looks a lot like this box. We have built applications. Those applications have really lived on a local machine. You have an executable that's created through the compilation process in Visual Studio. You can double click that and run your console application, or if you've been working on the WPF calculator, you can run up your WPF calculator from the executable, and you get a UI. The UI has some controls on it. Those controls let you do business logic. Everything's local to the machine. You're never going off to another server somewhere. You're never going to the internet, or you're never going to a database to do any business logic or processing. It's all just an executable on a machine. So if we think about how we can split this up a little bit, you often hear people talk about a sort of front-end and back-end development. And so there are tons of ways to think about the tiers or the layers of application development. This is kind of the most rudimentary one. Front-end development would be something like I've built a UI, so one of these WPF apps. Back-end is typically server-side or a database somewhere doing processing. So this is more UI-centered, this is more processing-centered, but you see it's fairly coarse-grained in terms of the technologies that you might want to use and where actually these things work. And so if you think about the WPF application that we've built, the back-end programming of the WPF applications that we've looked at have been something as simple as a view model, right? So the view model is truly the back end of that application, and the front end is just the XAML and the XAML.cs files that implement the actual UI and the controls that bind to the view model in the back end. If you want to split this up even further, you start to get something maybe like this 4-tiered approach, where I have a UI layer. And so if you think about off to the left here, there's a person sitting at their computer looking at some view. And so this UI is either the WPF application, or it's a web application, or it's an application on their phone. And then that UI is going to be bound potentially to a view model or something that's still on the user's machine. That performs some business logic. And so in the case of your calculator, for example, you can perform addition and subtraction and division and all of that stuff in this business logic layer, and that business logic never leaves the device. If you were to create a mobile application with Xamarin that is a calculator, there's still a separation between the UI or the view of the calculator and the logic that's happening on the calculator, and you don't necessarily have to go off to a server to perform something rudimentary like addition. However, in some cases, you do want to do that. So if instead of just a calculator, you were doing a calculator that also had RSA components or something that was really, really intensive in terms of processing, you might want to have a 3-tiered approach where you have some processing that happens on device. And so this is fairly rudimentary processing. It doesn't require a whole lot of resources. But if you had business logic that did require a whole bunch of resources, you could pass that off to a service that actually performs that business logic. And so if you needed to do encryption or decryption, or if you needed to make huge calculations like factoring calculations, you might want to pass it off to a service that is capable of running all that stuff in the background while your sort of device is not hindered some way by the usage of those resources. And then even one step beyond that, if you have a kind of data management situation like we had with the help desk application, you might have some logic that is intense enough that you want to perform it on a service or on a server somewhere, but you also probably have a persistence layer that actually is the model of MVVM that is persisting the data. So in our case, we did not have a persistence layer, but if we did have a persistence layer, we would be taking our support tickets and we would be storing our support tickets in a table in a database somewhere, so that when we launch the application again, we're not back at square zero. We have some support tickets that we had entered at the last session of the application. So this right here is a very traditional sort of view of a 4-layered or a 4-tiered web application, where I have something like a simple UI in HTML or XAML or whatever you want. Then I have rudimentary business logic that happens perhaps in JavaScript or something in the browser or on the client. I also have more intense or distributed business logic that happens server-side, and I have persistence that can be managed by the server-side business logic. And so if you think of something like the application that we're going to end up starting to build next week, you're going to have a situation where you potentially want to create a new course. And if you wanted to create a new course, the action would originate in the UI. A user would actually click a button that says create a new course, and then that would go all the way down to the persistence model and actually put a record in a database somewhere that a new course has been created, and it would take all of the data from the view that is bound to the view model, and then through a service call actually create a model from that view model and then persist that model into the database. So there are lots of ways to think about this kind of situation, but the thing that is the most important to sort of keep in mind is that what we've started in the previous slide is talking about front-end and back-end development. The other way to think about that is what is client-side versus what is server-side. And so here I have the view and some business logic that is on the device. It's on your laptop or your phone or your desktop. And I also have server-side code that is hosted on Azure or hosted on AWS or hosted on some sort of local server that you have at your house potentially, and I have a persistence model that is server-side, but it could be split among different servers. And so if I have maybe the most complicated situation that we've been talking about, I have a workstation, I have a web server that is implemented in Azure, so I just have an endpoint that we're going to talk about later, an Azure endpoint that is hosting my services, and then I have an Azure database server that is a different physical machine that is all server-side logic on the right-hand side of the screen, but it doesn't necessarily mean it's on the same server. All that means is that it is not local to the user. So the thing to keep in mind is anytime you are leaving your device, so if you're going from your phone to a server somewhere, or if you're making a double hop from your phone to a web server to a database server to persist data, each of these red arrows indicates a potentially very long period of time. Because you're going to have to authenticate, you're going to have to negotiate data transfer from each of these layers to the subsequent layer, so on and so forth. So as we get more complicated and we go from this situation all the way to something much more complicated like this situation, the number one thing we want to start thinking about is performance. And the reason is because these red arrows, these could potentially be very long periods of time to transfer the request to build a new course from your phone to the database. And if that is the case, no one will want to use your application. This is potentially the biggest of all of the architectural design considerations for something like a C# web application. And the reason is because C# itself has kind of a bad name in terms of performance. And so what we want to do is we want to use two very popular ways of dealing with performance to kind of maximize our efficiency. And so the first of these is multi-threading. So we have not talked about multi-threaded programming in C# yet, and there's a reason for that. And that reason is the web API library sort of innately gives you a much better way of dealing with introducing multi-threaded programming. And so when we get to server-side development in 2 weeks, we're going to start talking heavily about the async await pattern in C# as a thing that will help us with performance. So the idea behind multi-threading is you want the situation where a user can press a button and then have something happen, and immediately the user gets the responsiveness of the button back, and they can go along with their life. So they don't necessarily have to wait for this whole chain of events to happen before getting control of the UI again. What you want is your UI to be responsive, which means that you can click a button and then click another button and then click another button, and potentially all of these calculations are not instantaneous. They're just happening in the background, and once you get the response back from the server, then you can asynchronously sort of update whatever UI components you need, and the user is able to work at their own speed. They're not bottlenecked by the speed of your internet or how much sort of cellular data you have to use. The second thing we're going to talk about is data transfer. Data transfer can be extremely cumbersome if you're trying to send tremendous amount of information back and forth from these layers. So we talked a little bit about MVVM in the previous videos from last week, and really what that was about is kind of a purist take on how WPF binding is better in terms of software engineering than the alternative, where you just kind of update the UI using events in the background. We're going to talk in the next video more specifically about that situation and why MVVM is important. But data transfer, the idea here is that you don't necessarily need to understand all of the binding properties at the persistence layer. If you have a whole bunch of properties that are string properties that you're using to bind to labels or bind to text boxes or whatever, you don't necessarily need to duplicatively store data in the database. So a perfect example of that is if you want to have like a price of a thing So you could have a price of a unit, and that price you may want to have stored as a double or a decimal value. But the display should probably be bound to a string. So you could have a property on the view model that is a string property that basically just calls .toString with a C parameter to convert your decimal value to currency in the view model. You don't need that toString value in the database. So instead of storing it in the model, what you would do is you would only store the double value and then pass it to the view model. And then once you're in the view model, then you would actually reconstitute that string property. And what that's doing is it's limiting the amount of data that you're sending across these red wires, and that's boosting your performance because you don't have to pull the string out of the database. You don't have to wait for that string to be transferred from the database server to the application server, and then from the web application server to your workstation. So the very common pattern for doing this is called a data transfer object, or a DTO. And so we're going to make heavy use of DTOs as we go from next week into the next week and talk about server-side coding. So you're going to get a lot of hands-on experience with DTOs, and you're going to actually see how you can basically generate DTOs in a lot of ways from models. So you can have a model that expresses a DTO that has only the information that you care about showing for a specific view segment. So if you have a view that only has the name of a payee on a check and the amount and the date of the check, but the record for the check is 40,000 columns, you don't want to transfer 40,000 columns to just show 3 fields. You can have a DTO that only transfers those 3 fields, and then your application is much more responsive. And so those are the kinds of considerations we're going to start talking about in the next 2 weeks. So that is kind of a very high-level overview of what we're going to start talking about for the rest of the semester. And so what we're endeavoring to do is literally what we've done with these squares. We started with an application over the last several weeks, and what we're going to start doing is subdividing that application box into a situation where we're going to have multiple layers of code running on multiple servers or multiple machines, and that is going to let us do a lot more interesting stuff, like deal with persistence and deal with business logic both on and off of the device. So in the next video, what I'm going to do is I'm going to talk about MVVM and MVC in a little bit more detail than I did last week, because this decentralization that we're talking about in terms of splitting up that box into potentially multiple layers of code on multiple machines is really, really important. Decentralization is a very up-and-coming kind of concept, and what you will find is we're going to be able to go to a situation where we have one client-side or one server-side implementation that is some web services and a database layer, and this workstation component can be interchanged. So one of the most powerful things about stateless services is these things can be headless. We can have a phone app that calls into these services. We can have a website that calls into these services. We can have a text-based console application or a WPF app or whatever app you care about. And the client-side code can be made very, very, very small or very, very thin. And these thin clients can be interchanged as many times as you like. And what that allows you to do is have a whole bunch of services and a lot of logic and a lot of functionality that you can then distribute across a phone or an iPad or a laptop or whatever you'd like. So we're going to start the conversation with MVVM as a kind of central pattern and then move into MVC. And this MVC pattern is the pattern that is most closely followed by something like Angular. And so next week, we're going to start talking about HTML5 and Angular and how I would call a C# web service from Angular and HTML5. And so next module doesn't actually have any C# in it, and then we're going to use that module to actually build the rest of our multi-tiered C# application. So we're going to talk a little bit about MVVM. That's going to motivate us going to MVC. And we're going to talk about how decentralization kind of works in the context of decentralizing your data and the behavior of your data into multiple layers, even within just one application. So thanks for tuning in to this video, and I hope that this is a little bit illustrative of what the rest of the semester is going to look like and kind of sets the scene for the kind of web service stuff that we're going to get into. Thanks again, and I will see you in the next video.